Hello, so this is a revision video for CIE A-Level Chemistry 3.1, Electronegativity and Bonding. This is a revision video, so only the essentials are covered. For deeper explanations and for full video lessons, please check the links in the description below and visit chemistrystudent.com. Electronegativity is the power of an atom to attract electrons to itself. It's a relative value and doesn't have any units. The most commonly used scale to compare relative values is the Pauling scale, where fluorine is the most electronegative with a value of 4.0 and the group 1 metals are the least, with values ranging from 0.7 to 1.0. Electronegativity is really useful and can help predict whether a bond is likely to be ionic, polar covalent, or nonpolar covalent. The electronegativity of an atom depends on three main factors: the nuclear charge of the atom, the atomic radius, and shielding. The nuclear charge is really important because the greater the number of protons in the nucleus, the greater the attraction it can have to bonding electrons. The atomic radius is important because the smaller the atom, the closer the bonding electron pairs are to the nucleus of the atom, given a stronger force of attraction. A greater level of shielding means more inner shells and subshells, reducing the attraction between the nucleus and bonding electrons. Electronegativity increases across a period from left to right. This is because atomic radius decreases and nuclear charge increases, but the level of shielding stays roughly the same. This means a greater attraction between a shared pair of electrons and the nucleus of the atom. Electronegativity decreases down a group from top to bottom. This is because atomic radius and shielding increases. The outer electrons get further from the nucleus and are less strongly attracted to it. We can predict a bond type by comparing the Pauling electronegativity values of two bonded atoms. If the difference is very large, typically greater than 1.7, the bond is effectively ionic. Because the electronegativity of one atom is so much greater than the other, it essentially attracts the bonding electrons towards itself and ends up taking them and becoming a negatively charged ion. The atom with the lower electronegativity will therefore lose the electron density and become a positively charged ion. If the difference, however, is only moderate, so somewhere between 0.5 and 1.7, the bond becomes polar covalent. This is when the electrons in the bond are shared unequally. The electrons will be more attracted towards the atom with the higher electronegativity, and this atom will end up with a partial negative charge. And the atom with a lower electronegativity will end up with a partial positive charge. This is why the bond is described as polar, because it has two opposite poles to it, a negative end and a positive end. The greater the difference in electronegativity, the greater the polarity of the bond. If the difference in electronegativity between the two bonded atoms is very small or zero, the bond is nonpolar covalent. The bonding electrons are shared equally between the two atoms, and no atom has a greater share of the electrons than the other. Exam tip here: always remember it is the difference in electronegativity between two bonding atoms that matters. It is never the individual electronegativities themselves. You can have two atoms of very high electronegativities bonded together, but the bond is still nonpolar because the difference in electronegativity between them is very small.